All right, guys, welcome back to another video on the CyberPro Austin YouTube channel. I've got a really exciting one for you today. If you remember a couple weeks ago, I made a Python wordlist generator that basically generated passwords specific to a company. And it took input based on the street number of the company. It took input based on the company name, something the company sells, a couple other things, the street name that it was on, and there's one more thing that's just slipping my mind. But basically, it took the input of all those things and generated a ton of potential passwords, because a lot of times people will go into a company and they know that they're not supposed to reuse passwords, so they make something that's just, okay, I work at Google, so my password's going to be Google123 exclamation point, and so it does something like that. Well, basically, that generated millions of potential passwords that you could use in a penetration test against a company to see if any of them are using weak passwords like that. The other thing that people do is, rather than using passwords specific to a company, they use passwords specific to their own personal lives. And basically, what this Python generator does is takes input based on things specific to a person. So if you're going to use this, what you would do is spend a lot of time doing OSINT, getting all the information that you can to make this as useful of a generator as possible. Now, I'm not going to use this in Kali because I wanted to just show it on GitHub, because I think it's actually, this is like 450 lines of code. And I don't want this to be an hour-long video where I'm also generating the word list and I'm going through it. And the thing is, with this word list generator, I'll just tell you off the bat, it generates potentially hundreds of millions of passwords that you could use. And so there's not even really any way to demonstrate this as a proof of concept to you, because we don't have time to scroll through hundreds of millions of passwords. The only one that's going to be able to do that is something like Hashcat, just to use against a hash that you've got. So essentially, what I do is I have multiple functions here at the beginning that validate the input, that make it so you can't skip, or you can't put in an invalid input that has a space in it, because generally a password is not going to allow you to have a space in it. So the first thing is getting the significant other's name. So basically, a lot of times people will make a password that has their spouse's name and then a number afterwards. So I get the significant other name. We save that to a variable later on. Get the first name of the person. We get the last name of the person. Now we move into the next category, which is a very common thing that people do with passwords, is use their pet names. And, so it's like pet name, year you graduated high school, pet name, significant number that you use. And so they'll put that afterwards. But the thing is, not everybody just has one pet. Sometimes people have multiple pets. And so what I did here is basically first ask, hey, how many pets does this person have? And then you enter a number. Now, based on the number of pets that you have, so basically if you put in 5 for here, the person has 5 pets, and it's like, all right, enter the name of pet 1, enter the name of pet 2, and that's what happens down in this for loop. And the while true is, enter the name of pet 1, enter the name of pet 2, enter the name of pet 3, and basically until it gets down to however many you enter. If you entered 5, then when you get to pet 5, it'll move on to the next one. So then we get to children, because people do the same thing with their kids. They use a name, just the name of their kid, year that they graduated high school, year that they were born, some significant number, whatever, and then go down the list and just do that with their kids. So the same exact thing that I did with pets, I did with kids at the same time. So basically, if you know the names of the kids of the person, then you can do that. And now for get favorite thing, basically someone's favorite thing. So like you can see, I'm wearing a Cincinnati Bengals hat. I'm wearing a Cincinnati Bengals shirt. If I had to pick a favorite thing outside of my family, and it'd probably be the Bengals. So for me, if you're generating this, you could use the word mingles. Now, I will say that'd be useless because I'm not going to use my favorite thing in a password that I'm open about, that I love. Password is supposed to be something that only I know. So, but yeah, get favorite thing, basically just using something that, um, a person might be inclined to use, and then does it by that. Now we get down into the generate passwords function. But one thing that I will say about this, I made it in a way that, not everybody has a significant other, not everybody has kids. So you can skip these when you're going through the input. So for get significant other name, if you just hit enter, it'll just move on to the next one, and it's not going to generate any passwords about the significant other. Obviously, you're not going to be able to skip. I mean, the thing is with any of these, you can just put enter, 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 and it'll just put 0 passwords to the file. But, I mean, you're not going to want to skip first name. You're not going to want to skip last name. Pet names, you can just enter 0. Children names, you can enter 0 if they don't have it. And then get favorite thing, if you don't have any idea, I would just suggest putting something random that you might think would work, just, to give yourself something to work with. And then move on. So now we get into the meat of it. Now, in the company passwords one, I made a bunch of specific functions for all of them. This one, I didn't really feel like I needed to do that, and I was having some issues making it into functions, and so I figured it'd be easier if I just did it all in one thing. And this is the meat of the function, and this is where it gets very redundant, basically just the same thing over and over and over again, but I'll kind of just explain what happens. So I create an empty list with passwords, and then I've got all of this string of special characters assigned to a special char variable. So what happens is now I get into actually generating the I. And well, I actually get into generating the numbers, excuse me. And so what I did is for I in range 10,000, number gets assigned to, basically taking that integer and making it into a string so that we can concatenate it with the rest of the passwords. And then I also made another variable, number with zeros, so that when you've got a number like 1, that we're going to generate a password that is, first name, just myself, Austin 1. You're also going to have Austin 0001. The reason that I did that is because we live in a society where 4-digit numbers are extremely common. First of all, 4-digit numbers in terms of years, like, you were born in whatever year, it's a 4-digit number, your bank PIN is a 4-digit number, lots of different things, for like your credit card on online shopping, the last 4 digits are exposed, your social security card, the last 4 digits. So a lot of people just kind of are accustomed to using 4-digit numbers. So I didn't want to miss any of those just by only writing, one number. So basically every possible number that I was using in this, which is in the range of 0 to 10,000, is used here. Also making sure that the ones that only have 3, 2, or 1-digit numbers, they will be printed normally. So basically for the number 18, Austin 18 would have Austin 18 and Austin 0018. So we've got both the normal number and the 4-digit number. But basically what I did is I'm just at this point taking the stored variables and I'm just going down the list and doing it. So basically this is what happens in this for loop. For a number in the range of 10,000. So basically let's just say the number 1. So the number 1 is made a string here. The number with zeros is made a, that number with, something else added onto it. So what I do is I just take all these different variations. Now, for a character, for char, in special char, which is every single one of these, Now we start generating these passwords with the special characters added into it. So basically, for every number, and then within every number for every special character. So you can see how this is generating extremely large amount of passwords. So basically, for one in range 10,000 for every special character after that. So basically, you want to find out how many passwords this is going to generate. You can basically just do a lot of multiplication. So however many special characters are here, 10,000, and then every single one of these things. So essentially, for every character and special character, we go down here and we do this. And then if it's less than 1,000, we also want to add in the number with zeros and the special characters, just so we're having the 4-digit numbers for the ones that don't have it. So that was just the example of first name and last name. So these are specifically just passwords with the first name and the last name of the target. Now we get down to the significant other name. It's the exact same thing. We take the input, we just generate the basic passwords that have no special characters, significant other name, number, significant other name. And then the number with zeros first. So then we do the same thing for char and special char. And then down here. And basically, this is just very repetitive, but it's the exact same thing. I could have broken this up into different functions, but I didn't really feel like the functions were doing anything different, so I just left it the same way. I wouldn't have shortened my code at all. So then for child name and children's name, and it just goes down. It does the same exact thing. And then favorite thing. So now we're done. We've generated all the passwords. That's the function that has all the passwords. Once we've completed all of that, now we move into the next bit, which is the last function in my code, which is just creating the file name, which this will generate a file based on the person's name. So if you were doing one against me, it would be, the resulting file would be austin.txt, and it writes all of these passwords to the file. Now, when we actually start getting into playing out. So it's not until line 327 that we actually start doing anything. The first part was all just defining functions. So 327, the first thing it asks you is about what the significant other of the person's name is, assigns that to significant other name variable. First name variable gets assigned get first name, last name, get last name, pet names, get pet names, children names, get children names, favorite thing, get favorite thing. So then what it does is I assign combined passwords, the variable of the function generate passwords. That's going to generate literally hundreds of millions of passwords if this person has multiple pets or multiple children. And then we basically put this in, we assign the function file name to the variable file name. Now we get into the exact same thing. I copy and pasted the code that I made from the company Wordlist generator, because I basically wanted to make sure that we're, continuing to keep everything the same way, that we're checking for all of the, obvious changes in words. Like if you're using a lowercase a and replacing that with the @ symbol, it makes the password more secure on the complexity chart, but it's not something that's extremely difficult to guess that you're doing. So basically, all the different instances where people are replacing letters with numbers that just look like the letters, I went ahead and what I do is I take all the passwords that are generated, I create a new file. That's the second thing I do. I replace all of them, so like for capital A, I replace with a number 4 in every single password that's generated in the list. And then I create a new file, which is just a temporary file that's going to be deleted before this program's even finished executing. It puts all the passwords into that file and just, saves it and waits to do the next thing. And it goes down the list. It replaces capital B with the number 8. It replaces E, both uppercase and lowercase, with the number 3. It's replacing I and L, capital I and lowercase l with the number 1. It replaces uh, O and O, both the uppercase and lowercase, with 0. We are replacing capital T with 7. We're replacing S with 5 and uppercase S with 5. And then every single one of these just gets put into one function at the end where they're all, getting replaced. So, yeah, so this is just very, very redundant. You could argue unnecessary, but, if we're going through the time to generate passwords, and the thing is, this is so simple to use. I mean, it does take some time to actually generate and write 100 million passwords to a text file, but if we're going to go ahead and do this, we might as well just check all of our boxes along the way. And so after we do all of this, we generate all the passwords with the special characters and the, numbers replaced with the special characters. Now we move into, we create a temporary file with all of the modified passwords. We concatenate the original file with the modified passwords. So basically the A file is added to the new file, the B file added to the actual file, and just goes down the line, all of these. Now, this is the only place that we even use a module at all. We imported the OS module at the very beginning, and this just removes all those temporary files, so we don't have these massive files just sitting on our system doing nothing. And then after that's all done, we write all of the original passwords to a file, and then we generate them all and save it, and you are ready to go. And I made sure that I also included how many passwords were generated in the first place, so you've got everything in there. The remove duplicates function, I said this in the last week's video. If you didn't see that, it was something I was trying to do that would basically remove duplicates within this, because some of them, it's not going to be the same password, so when you're going through this, not every password is going to have a O in it, but we're going through and running that O and replacing it for every single one of them. So you will have some duplicates because we're just making all of these together. I tried to do that, but I felt like it was taking so long doing that there wasn't really any harm in having all the duplicates other than it just being a massive space. But here's the thing with this. You have no use keeping this on your desktop at all, or anywhere on your computer. When you make this file, as soon as you're done running it, just delete it and get rid of it. I mean, this is gigabytes large. This is hundreds of millions of passwords that you're using. So there's no reason to keep this stuff. As soon as you're done, I mean, the first command that you should be running after hashcat is remove austin.txt or whatever else, because you don't have any reason for it. It just takes up a lot of space. So I went basically with just trying to skip over that, make it run faster. You're not going to have any harm in having a duplicate word in there. And this is basically just going to help you do something specific to it. But yeah, so the main goal of this, you should not be using passwords that someone can easily guess. Well, let's just think through the general, just fundamental knowledge of what a password is. A password is supposed to be something that only you know. All right. But what people commonly do is use a password that they have some kind of close connection to that they will remember, not thinking at the same time, hey, someone might know this, and they might have a very, easily be able to guess this, like for example, people will use passwords like child name, year that they were born, year that the child was born, different stuff like that. It's like you've got your birthday public on Facebook, you've got pictures of the kid, you've got the kid's name, you've got the kid's birthday on Facebook, and so like all these different significant dates. We post this stuff online while people aren't thinking anything. You're not thinking anything about it. Like, oh, I just posted my birthday on Facebook. No one's ever going to use that maliciously against me. But They might, and the internet is a hostile place where there's a lot of people that will try to use information on you. So someone can leverage their OSINT skills with this and do it. And ultimately, what this isn't me just trying to, have a desire to get everybody in the whole entire world hacked. But my main desire is that, hey, we've got something that we can use to test organizations with, that to make sure people aren't using these types of passwords that can easily be guessed. Because you may have had an instance where basically someone shared their password with you and told you what it was, and you heard it and it was like, that's not a secure password. But the reality is, Rock You 2021, just random stuff like this is not going to hack into that account. You understand what I'm saying? It's complex enough to get past a general word list. It's not complex enough to get past just guessing based on OSINT skills. And this word list is going to ensure that that's not going to be able to happen. So, literally generates hundreds of millions of passwords. If you want to try it out, just go to GitHub and check it out yourself. I think, though, that you guys will really enjoy this video. If you did, please be sure to leave a like and subscribe, and I hope that I can continue generating some really cool Python projects for you guys to use and check out yourself in the realm of cybersecurity. Thank you guys for watching. Hope to see you next time.